Okay, so this is our first question for the review. Hopefully this actually will record, unlike yesterday, it wouldn't do it, so we're going to try it again. So the key aspect of this question is the fact that it said that it is symmetric and no outliers. Since it's symmetric and no outliers, we want to use the mean, okay? So if there were outliers, we'd want to use the median. Those are your measures of central tendency, okay? So you need to be able to say, okay, median, outliers, mean, no outliers, okay? So what we're going to do is we're going to add all these values up, and then 1, 2, 3, 4, 5, 6, divide by 6, okay? Okay, so this talks about the mean, so divide it by 6, you get 146.50, okay? So don't forget, if you had to do the median, just to remind you, we need to put these into order. So 132, 140, oh, two 145s. Okay, and then the median is going to be the middle values. Since it's an even pair, I'm going to add those two together. So then my median, divide by 2. So then my median's here. Then remember, so the median's right here. Your Q1 would be this value, which would be 140. This value right here would be 156. That's your Q3. So then that's your lowest value. That's your highest value. So when you make a quick little box plot, so then 132 is going to go there. My 140 is my first box. 145 is there. Q3 is 156. So then there's my box. There's my whisker. And then the highest value is 161. And there's my other whisker. And then my IQR. Remember, is Q3 minus Q1. So it's going to be 156 minus 140, which is 16. And then your outliers, so lower bound is going to be Q1 minus 1.5 of your IQR. And then Q3 plus 1.5 your IQR, and that's your upper bound. Okay, those are your things. Those was our medians and all that stuff that we covered. This is our next question, talks about simple interest. I will be attaching the formula sheet. I'm going to get rid of this X here, or the multiplication sign, put a dot or something to recognize that that's multiplication for you. But what we're going to do here is your simple interest. This is I is equal to PRT. So then you're going to go I, your principal is 5,000, your rate is 0.05, and this is for 6 years. Remembering that T is always in 6 years. So we've got 5,000 times by 0.05 times by 6. So I is equal to 1,500. Now, you got to be careful what the question's asking for. It says, what's the balance? So then if it wants the balance, you're going to take the 5,000 and you're going to add 1,500 to it. And you're going to get $6,500. And there's lots of typos in that one. And you can fix that. Okay, any questions on simple interest? Because it's simple. Are we good? P is your beginning balance, your principal. Rate, time. Okay, compound interest. So Erin is investing into a mutual fund that is compounded quarterly. She plans on investing $12,000 for 15 years at a rate of 11.23%. What is the balance at the end of 15 years? So our compound just simple as that. So then we're going to go B is equal to 12,000, 1 plus our rate. It's quarterly, and 15. Okay, so if you type everything in correctly, your calculator, you should get 63,193 and 3 cents. That's the balance. Now, if I ask for the interest earned, you subtract your principal amount, and you find out that this is your interest earned. All I did was come through and subtract out my principal amount. Okay? So this is continuous compounding. Jane has the opportunity to invest into a continuous compounding account. She'll be required to deposit a minimum of $4,500 for 20 years. The account has been averaging an APR of 8.5%. What is her balance at the end of 20 years? So our formula is B is equal to P, then the exponential, and then we go R times T in the power. So then our principal amount is 4,500. We're going to go E, and then our rate, and then our time for 20 years. So if you do that correctly on your calculator, you got about $24,632.76. Again, if I just come in here and I just subtract the principal amount, I can see the interest earned. Okay? So here's our next question. I'm going to zoom it out just a little bit. So this is future value of a periodic deposit investment. I kind of threw that in there. This was just kind of for my benefit. So Brad and Linda opened a savings account that has 3.25% annual interest rate compounded monthly. They deposit $7,500 into the account each month. That's how I know it's periodic. If it just says they deposit $7,500, not each month, that's how I know that it's going to be a single deposit. But because we're depositing $7,500 into it each month, it's periodic. So then that formula is and so then we're going to fill it out. So it looks something like that. I'll scoot that over, and then we'll do. Okay, so I kind of wanted to get a little head start. This is how much they would have after the 20 years, okay? So again, if I'm looking just for how much interest did they earn, well, I need to take out their principal. So they deposited $7,500 12 times. In 1 year, that's $90,000. They did that for 20 years, so that's $1.8 million. So when I subtract that, you can see that the account actually only paid them $730,000 in interest. So it's a little bit low. Value of a single deposit. All right, so Max wants to take a trip in to Brazil in 8 years. She knows she'll need about $9,500. How much should she deposit into an account now? That pays 5.25% interest compounded daily. Round your answer to the nearest dollar. Okay, so this tells me this is the end. So we're looking at how much they need to deposit just once, okay? So that's why it's this formula here. So then we're going to go with and on top, and then we're going to go 1 plus the rate. Oops. Let's get that right. And then it's compounded daily. And they're going to leave it in there for 8 years. Okay. So Max, she needs to deposit $6,242.13 into the account and leave it alone for 8 years for it to grow to $9,500. So she needs approximately $3,300 in interest. So this is another future value of a periodic deposit investment. Again, just want to make sure we have the practice that we need for the final. So this is our formula that we have. Then I substitute it in. So I'm going to pause it and use my calculator. So entering into calculator, she got $43,626.11. This is the present value of a periodic deposit investment. So how do I know it's a periodic deposit? Well, they should deposit monthly. So that's one of my key phrases, that it's going to be periodic. And then they tell me that at the end, I want $1 million. Okay. So I need to know how much I need to deposit now to get that $1 million. Okay. Okay. So we used our formula. I substituted in. I do the calculations, and I find out that they need to invest $1,606.30 each month for the next 35 years to get $1 million at this interest rate, which is pretty low. This is not going to be on the test. It takes you guys too long to do this, so I'm taking this one off the test, okay? So the checking questions are off. Log rules, not on the test. Yaw marks, not on the test, because you guys didn't get the chance to do it. Exponential depreciation function, not on the test. Didn't get a chance to do it. Straight line depreciation, not on the test. Sales tax will be on the test. So you're going to take 8,000, I know, but you'd be amazed at how many screwed that up on the test. No. Anyway, so you're going to come up and just do a quick little multiplication. Oops. So we multiply that across, you get a sales tax of $460. So then there's $8,460 on the total. Okay. So sales tax will be on there. Like I said, straight line's not on there. Exponentially depreciation's not on there. Ratios, not on there. Social Security and Medicare, we didn't get a chance to get to it. Health insurance, not on there. Pension, again, not on there. Commission rate, you got your agency.